Tuesday night, the 23rd of September, 2025. I thought I'd give you a little idea of what I have to do behind the scenes here, behind the curtain. What we got right now is a 1/10 of a second view using ASI live stacking of Messier 22. It's probably the brightest globular cluster visible from the northern hemisphere, although it's about 20 degrees below the celestial equator, so it doesn't give quite as good a view, actually, than the M13 Hercules. Now, this is what is called the histogram. It has the two sliders on it I described previously. The one on the right basically darkens the background sky, and the one on the left determines how bright, how sensitive the ZWO imager, the display, not the ZWO imager, but the display is to the signal that's being fed by the CMOS circuits in the sensor, the ZWO sensor. I have other functions here. I don't play with brightness, contrast, and saturation. I usually leave those alone. I may explore them in the future. I set the ZWO imager to self-cool. I'll get a check mark over here when it reaches minus 10 degrees centigrade, which is about 10 degrees Fahrenheit. The exposure here of 0.1 seconds is roughly that equal to about a 4.5-inch scope. I am about to boost it up, and we'll have another look at it. Okay, doubling the exposure time to 0.2 basically takes half of, well, I think it was a 4-inch scope before. It takes half a 4-inch, adds that to the 4, so 4 plus 2 is 6. So this is basically a 6-inch scope exposure of Messier 22. The sky is decent. The middle third all the way down to Altair, and below that is dark. Right now, Vega is almost overhead, and Deneb is approaching. So we got a pretty good sky tonight, and I want to launch into the NGC6500 through 6600 series, picking and choosing among the various studies available. Okay, we're now having a 5-second view, which really jumps it up there. This is the equivalent of about a 30-inch scope. You can see how bright the background sky is. I can play with a histogram, and I try to describe how you bring this right histogram over to about this low point where it's just barely touching the x-axis. And you can change the sensitivity to light by moving the left pointer, and typically I put it right. Well, that's really nice right there aesthetically. But when we're doing galaxies, we want the bright background sky to be a bit lighter than that. 5-second views like this, stacked, are what I use for the NGC series, and it gives slightly better views than I did with the Rev 2 imager previously. Plus, we get the virtue of having a nice wide field of view with the capacity to zoom to whatever magnification I pretty much choose to. Right now, we're operating at 60x. The exposure time we will be using tonight is actually 10 seconds. You get fewer stacks, so it's not quite as good at eliminating background luminosity. I am not using the Optilon filter. I found that last night, without using it, it actually did as well, if not better, than including the filter, especially when I had hoped it would improve the views of Saturn, but that's still questionable. So here's our 10-second exposure time, and that's what we'll be using this evening. As far as zoomage is concerned, we start off at 20% in ASI stacking, and then which is roughly about 60x. We can double that, 30 and then 40, and then we get something more like 120. When we go to 50, we're up to 150x. 240, this is really bad looking here. It's possibly I have to do the refocusing, but it could also be due to sky conditions down south. When we go up to 80% zoom, we're now exhausting the capacity of the scope to resolve down to 0.8 arc seconds under perfect seeing. And when we go to 100% e-zoom, we're using all the pixels to deliver light to the scope the image quality, the brightness of studies in the field gets better, but the image quality does degrade because, for some reason, it's so easy to overpower the matrix of pixels with luminosity from neighboring points on the screen. So that's pretty much it. I'm going to go and reset the snipping, Microsoft snipping tool, which I have had no problem with whatsoever on Windows 10 using my older HP laptop. So now we're going to go back to viewing, and we're going to start off with NGC somewhere in the 6500 range, whatever attracts my attention most. Messier 22 once again, but now resizing the screen to fit into the, so we're only seeing that which is displayed on the screen so we can get the maximum amount of image size possible without having the distraction of the rest of the controls that are available in the application. All right, we're now well into sky dark. It's 8:39. The sun set a little bit before 7 o'clock this evening. Typically, it takes an hour and a half, but also slightly less when we are near the equinoxes because the sun makes a more direct flight down lower in beyond the limb of the Earth, casting less light into the night sky. Earlier, what we're looking at here is NGC6500. It's either one of these two galaxies. I love the way the screen looks. I am going to call up the data, and based on the data that I get back from it, let's see if we can determine which of those two galaxies is actually NGC6500. I would describe both one as being face on and the other kind of edge on. And according to this NGC6500, the Gemini 2 galaxy in Hercules, it's magnitude 12.1, kind of funny because it's 2.2 by 1.6 arc minutes in size, spiral of the AB type, 138 million light years distant. So perhaps the only thing that can help us out here is how bright the central star is, or the central core of the galaxy. It's at right ascension, 17 hours, 55 minutes, 59 seconds, with a declination well into the sky's middle third of plus 18 degrees, 20 minutes, and 18 seconds. There's also a galaxy up here. I'll do a quick zoom in on these two galaxies there. We should be operating at what? Yep, 150x. And then we'll have a look at the galaxy at the top of the field. This one's kind of oblate, which might very well be it. This is a little more edgy. This may be a little more oblate. The cores of the galaxies look very similar. I do believe we've solved our mystery. This is NGC6501. Everything shifted a little bit to the left. I'll give you I think I already gave you the data on NGC6501 because we were trying to compare the two galaxies. But this is clearly our NGC6501, and this is our 6500, and the data on 6501 is about to pop up in Hercules, magnitude 12, 1.8 by 1.6, so more of a football-shaped galaxy. Spiral with a lowercase a, it's got a brighter core, and it does appear to be the case. 137 million light years distant, puts it at about 80,000 light years in diameter. We're at right ascension 1756.03, declination plus 1822.23. As the scope navigated, I wanted to go to NGC6504, but at plus 33 degrees and looking to the west, the scope was partially blocked by a roof try. Okay, so instead, I opted for NGC6509. Now look at this as a very nice edge-on galaxy, but the core is not stellar. It's only bright and it fades off towards the spiral extensions. This galaxy is an Ophiuchus. It's magnitude 12.5, 1.6 by 1.2 arc minutes, spiral with a bar, but a CD. A lowercase CD means well off to the right on the morphological chart, the Hubble de Vauquelaire's morphological chart, which explains why we don't have a very bright core. 84 million light years distant, puts this at about 50,000 light years in diameter. Right ascension 1759.25 with a declination 6 degrees 17 minutes and 11 seconds north. Thought we might well like some brief zoomage on this edge-on spiral, relatively immature spiral. And there we are at 150x, which I'll probably only push things to this evening, given the oblateness of the stars. Not the oblateness, but the focus isn't too bad. I could sharpen it up a little bit, but I'll wait till the lens cools and the OTA cools a bit more. All right, we all know what this is. This is the Trifid Nebula. NGC6500-6600, it's also known as Messier 20. Magnitude 6.3, 28 arc minutes in size. Some 67 stars make up the open cluster. The brightest is magnitude 6, so that's what we're seeing right there, I believe. It's an emissive type nebula, and you can tell that because it's got a reddish appearance. 2,700 light years distant. Right ascension 1802.42 and a declination of minus 2258.18. A little past culmination. I think it might be worthwhile to center it up in the screen and maybe push the magnification a little bit. And then let's go ahead and play with the histogram, although I don't really like doing that, but we don't have the deep sky filter in the scope, and that might have improved the presentation. Oh no, we're doing really well with just the histogram itself. Nice view. I'll push the right histogram up to where it just makes contact with the lower x-axis bar, and there is our look of Messier 20, NGC 6514. Oh, by the way, the view here is really astounding at 60x. We're also seeing extended nebulosity in this direction here as well. I like these settings work well deep south, but they're probably not going to work as well when we go north again. Well, because I fooled around with a histogram and fell in love with the Trifid nebulosity, this is very, very artistically nice, but we're not getting as good a view of NGC 6517. And what do you think it is? Globular cluster in Ophiuchus. So what I'm going to do is I'm going to put my right histogram where I showed you before, and then I'm going to push it out a little bit to brighten the field. And there we do it. A little bit. There we have it. Very nice view. Let's zoom in. Let's go to 50%, 150x, and here's our view of NGC 6517, globular cluster Ophiuchus, snake charmer, magnitude 10.3, a mere 1 arc minute in size, with a magnitude 16 stars, and many of those are being resolved. It's a class 4, so a little more condensed than the average, 34,000 light years distant, but very small for 34,000 light years. After all, Messier 13 at 25 or 6 is some 17 or 25 arc minutes in size. We're at right ascension 1801.50 and a declination of minus 8 degrees, 57 minutes, 31 seconds. Wow. Sagittarius is post-culminatory. I'm kind of tilting off towards the garage roof. But this is a fabulous view of the Lagoon Nebula, NGC 6523, also known as Messier 8. I'm using the same histogram settings as I used on that last globular cluster, so I think we've nailed it. M8 is magnitude 5, 45 by 30 arc minutes, just about filling this, what I consider to be a 50 arc minute field of view. It's an emissive type, obviously. You can see the red color in it, caused by the excitation of hydrogen atoms. Right ascension is 18 hours, 3 minutes, 41 seconds, with a declination of minus 2422.48. What a nice view. Let's go ahead and expand it out a little bit. And here we have, oops, I wanted to be able to, let's expand it out. I should be, oh yeah, there we go. So there's our nebula, there's our open cluster. This turns into that. That started as this. And these, some of the brightest stars that exist, are progenitor stars, and they will explode and illuminate distant, dark, cold, dark matter to make more of these, which will then make more of these, until the process goes round and round and round. The galaxies mature, use up most of their cold, dark matter, and then they begin to shine with more solar light rather than the brighter ultraviolet stars, brighter in the ultraviolet stars that are progenitors of the entire process. Well, apparently our last study was the open cluster, and now we have the nebulosity as NGC6526 in Sagittarius, 40 arc minutes in size, 4,300 light years distant, right ascension at 18 hours, 4 minutes, 6 seconds, with a declination of minus 24 degrees, 26 minutes, and 30 seconds. Fabulous to see you once again. Okay, we've now moved on to a globular cluster, NGC6535. It's in Serpens, the serpent. Magnitude 9.3, very small, 1.3 arc minutes in size. The magnitudes of the brightest stars are magnitude 12.8. Impressive. However, it's loosely constructed, a class 11 of 12, 22,000 light years distant. So once again, very small. Great Hercules cluster is at least 15 times that in apparent size. Right ascension is 18 hours, 3 minutes, 50 seconds, with a declination pretty close to the celestial equator of only minus 17 minutes, 51 seconds. What we're probably not seeing here is a planetary nebula in Sagittarius, NGC 6537, without a nebula filter in here or even a dark sky filter. You can't suppress so much of the background light to make it clear that you're distinguishing between a star and a planetary. This one's magnitude 12, only 5 arc seconds in size, with a magnitude 19.5 central star, 2,900 light years distant. We're at right ascension, 18 hours, 5 minutes, 13 seconds, and a declination of minus 19 degrees, 50 minutes, 34 seconds. We'd have to figure out where we expect to see this at this declination. Okay, what we're seeing here is a rather nice globular cluster. It's NGC 6539 in Serpens. Push it up. Magnitude 8.9, 2.5 arc minutes in size. Looks pretty large to me. The stars look perfect. Magnitude 15.9. Oh, these guys are quite apparent at magnitude 15.9. I believe the scope can go down to about 18, but we're so deep south that I can see luminosity in the sky. We wouldn't be able to accomplish that tonight. This is a class 10 of 12, 26,000 light years distant. Right ascension 1804.49 with a declination of minus 7 degrees, 35 minutes, and 11 seconds. Let's push the magnification up to 150 and leave it there. We're now having a look at a deep south globular cluster in Sagittarius, very bright, magnitude 7.5, fairly large, about 8.4 arc minutes. So it pretty much about a quarter, fifth of the field is the globular cluster. Magnitude 7.5, 8.4 arc minutes in size. Those stars are pretty bright. Magnitude 12.8 is class 9, 8,200 light years distant. Hard to figure how Messier and Machine missed it. It's a class 9, 8,200 light years distant, not quite as close as Messier 4 and Scorpius, but fairly close. Right ascension 18 hours, 7 minutes, 20 seconds, with a declination of minus 24 degrees, 59 minutes, and 53 seconds. Okay, we may be getting a little bit of a partial obstruction here for NGC 6550, which I believe is either this galaxy or this one, fainter one. Let's look at the data. Galaxy in Hercules, 6550 is also 49, magnitude 13.7. This looks a little brighter, but let's go ahead with it. 1.4 by 0.4 arc minutes. Both of them are Aegean galaxies. But this one's a spiral with a lowercase bc. The core in this one's a little too bright to be a lowercase bc. I suspect it's that galaxy there. Some 301 million light years distant, puts it about 100,000 light years in diameter. We're at right ascension 1805.49, declination plus 18 degrees 32 minutes. We may be getting partially blocked. I am going to have to jump forward for more studies that are further to the east. Let's do a little zoomage so we can see both of these galaxies together. Very, very nice. What we hope to see here is another one of those planetary nebulas, but I believed it was large enough to see. It's NGC6500-6700 planetary in Sagittarius, magnitude 11.5, 11 by 7 arc seconds. So we should look for something that's fairly oblate on the field. It's got a magnitude 15 central star, and it's 11,800 light years distant. Can't say that I'm really seeing much that would account for it. Have to look at this more fully. We've pushed the magnification up. We're getting oblate stars. We're at minus 19 degrees 4 minutes 34 seconds with a right ascension of 1813.45. That's as much time as we're going to spend on it. All right, we're now in Ophiuchus once again, mostly renowned for globular clusters, but this is a galaxy in Ophiuchus. Let's see if we can describe it a little bit. Bright central core. It looks like it looks like an eyeball. It looks like the spiral arms have rung completely around it, so it could be an annularized spiral. Condensed core with an even brightness going out in all directions. It's probably a class B. Let's look at it. NGC6570, galaxy in Ophiuchus, magnitude 12.7, 1.9 by 1.1. That explains its shape. It's a spiral of the B class, spiral capital B, which means this is a bar. And typically these galaxies typically only have 2 spiral arms. But it's got an M, and I don't know what that refers to. 104 million light years distant, so maybe 30 to 40,000 light years in diameter. Right ascension 1811.07, declination of plus 1405.33. We'll go up to 150x for our final view. Okay, what we're looking for here is another one of those alluring planetary nebulas that we have not been able to identify particularly well because they're so small. This one's magnitude 8. I suspect it's that baby right there. 15 by 12 arc seconds in size. Yes, it certainly has a certain oblateness to it, but also a certain color to it. Many of them have that opalescent blue, bright blue appearance. Got a magnitude 12 central star, which we cannot distinguish at all at this magnification. We can really pump it up, but I don't think it's going to do any good. This is 200% E-zoom, which is roughly 600x. 5,700 light years distant. Right ascension 1812.06. Declination plus 651.12. That's our view. Here we have a rather interesting open cluster in Sagittarius. NGC6583 is a magnitude 10, only 2.8 arc minutes in size, some 35 stars, a class 2-1. Wish I could remember what that was all about. 67, I think class 2 is reasonably well distinguished against the background field of stars. And a class 1 is fairly condensed with stars of very similar magnitudes, which is the case. All right, it's 6,700 light years distant at right ascension 1815.49 with a declination of minus 22 degrees, 8 minutes, 12 seconds. The sky is fairly luminous down there because I have to keep adjusting the histogram, but it seems to be improving. Hey, NGC 6590 is a vague nebula and open cluster in Sagittarius. It's also NGC 6595, magnitude 7, 11 arc minutes in size. You can see the nebulosity here. I can kind of play with this a little bit to see if we can bring it out a little better. Oh yeah, around these 2 stars in this region here. There's some 30 stars in the open cluster. It's a reflective nebulosity. The open cluster nebulosity is about 11 arc minutes in size. Right ascension 181704 with a declination of minus 1951.57. I have discovered I can't go much more than 15 degrees in declination with the sky progressing sidereally so far to the west. Otherwise, I get blockages of the aperture. Okay, we've returned to the Ring Nebula tonight, but I have to tell you, I doubt we're going to see those galaxies, the IC and the MCG. The MCG is somewhere over here and the IC somewhere over there. Unfortunately, we are getting slight aperture blockage. So what I'm going to do is I'm going to push it up a little bit. Let's see if we can, oh yes, I can see the IC galaxy here. Let's run it back just a little bit to 30%. Okay, it probably does need that additional magnification. We got a great view of the IC galaxy last night. You could actually see the S shape of its spiral arms. And I do believe this is our faint MCG galaxy there. So what I'm going to try to do, because we're going to go out on this, I think I'll do a 30-second exposure because we've got some aperture blockage and see what we can turn up. Okay, here is our 30-second view of the Ring Nebula. Partially blocked aperture. We have that spiral S galaxy over here. We've got some elongation of the stars. I may reiterate it. And somewhere over here is our MCG galaxy. I can't quite pick it out. It should be much more apparent at 30 seconds, but we do have some issues right now with the background luminosity. This shouldn't be it though. This is our spiral. It should be right about in this region here. Our MCG galaxy is here, and our IC spiral with its spiral arms being visible there. Clearly we see the central star of the ring. We are seeing some texture around its border. We see the internal nebulosity, which is greenish blue there. The 13.1 magnitude star is quite bright. We're looking almost overhead, but we are getting a little bit of that aperture block, and I just shifted my body around and it could affect the view. So let's go back a little bit to 30%. So 20% view is 60. So now we've added another 10% to 60, that's 30, and we're now operating at about 90x. It looks to me, I thought the nebulosity was right here, but this looks more nebulous here. The spiral is quite nice. So all I can say about it tonight is, because we're getting a little aperture block, the sky looks quite good, but then again, my eyes are looking at a screen. You can see with every iteration of 30 seconds, the screen's getting a little bit brighter. So even at 30 seconds, though, we're not quite getting exactly the same view we did the previous night. Oh yeah, look at that. I just ran the left histogram slider over to the right because the bell curve indicated to go to the right a little bit. And now we're getting the spiral arms, quite apparent, the S shape to the IC galaxy. Let's have a look over here. Ah, yes. This is probably the location of our MCG galaxy. You know what we might want to do? Let's try 60 seconds just for the heck of it. Well, we've just completed our second pass at 60 seconds, and it hasn't improved it any. Basically, all you would get is about a 0.8 arc minutes deeper sensitivity to light. Here's the galaxy. The problem is it's not finding matched triangles, so it's not really able to layer image on image. So the bottom line is we're probably not going to get any better view. I'm going to wait another 30 seconds and give it one more opportunity to stack. I've got the histogram set up just the way I like it. And that basically means the left histogram is set where the curve is just touching the base of the x-axis, has a peak on the y-axis, and the right histogram setting is where, I'll just slide it over a little bit, right histogram setting is set where the curve is just starting to touch the x-axis. So it's inclusive of numbers, and the numbers range from about, I'd say about 500 to 20,000, but that's a guesstimate. We've had our third pass. I don't see any improvement in the view. I am going to bid you all a carpe noctem.